Hello everybody and welcome to the Device Doctor. If it's your first time here, I'm not an electronics technician, just a guy who likes rolling up his sleeves and giving broken devices a second chance. From dead phones to retro computers, I'm all about practical fixes and a bit of DIY spirit. And for those of you popping back, cheers for sticking around. You know how it goes, we've got tea on the boil, tools at the ready, and another gadget begging for a bit of TLC. Whether it's a cracked screen or a device that's completely given up the ghost, we'll have a go at sorting it. So if you fancy learning a few tricks, having a laugh and watching me occasionally stuff things up, hit the like and subscribe button. With the compulsory plug out of the way, let's head over to the bench and meet today's device.
Today on the bench we have another ZX81. This one came to me, as you see it, just a plain board. Obviously no composite mod. The 7805 is still in place. This one is a good question. An issue 1. So hopefully you can see that in there. So yeah, so this is an issue 1. What else we're going to do? Put a composite mod in it, obviously, and get rid of this 7805 regulator. I'll replace it with another one of these. And we'll show you the power difference as well when we're doing that. Bit of backstory for those that are interested. The Sinclair ZX81 emerged in March 1981. It has a bold attempt to make home computing generally affordable, shrinking the complexity of the computer down to just a handful of components, memory and keyboard. It followed the ZX80 but pushed it a little bit further than the ZX80 in that it's fewer components, less complex, lowered the cost to the system as well. And you could buy these in either a kit form where you assemble them yourself or pre-assembled. I won't show you replacing this, you've already a video on that, but we will come back and I will show you the power differences once I've done it. Hopefully you can see there that it's drawing a lot less current through, or ampage I should say. That will stay pretty well cold the whole time. These will still be fine. These chips, it provides them with the right voltage. So yeah, and that's why I tend to change them. And while that's running, just to make sure we're all good. Yeah, so here we have our 9 volts coming in of our power supply. Here we have 5 volts. So it'll be 5 volts. So it'll be 5 volts. And 1, 2, 3, 4, 5. So this one, yep. Beautiful. So we can shut that off now. Okay. I'm just going to clean up this lot here. Looks like there's actually the remnants of a pin in there. But,
One eternity later.
That's about it. You just need to make sure when you're putting these in, sorry about that. But when you're putting these in, there's a little nick up here, and there's a little sort of looks like a half moon on the board. That just denotes where the first pin is. So, what am I doing? What am I doing? Aha. Would help if I get the right size, wouldn't it? Oh, I mistakenly grabbed a 16 pin and I need an 18 pin. That was silly of me, wasn't it? You don't all have to agree with me at once. Alright, there we go. Now, so one way of doing this, just to make it a bit easier for yourself, you can technically do it one-handed, but I don't see the point in struggling. I'm just going to whack a bit of blue tack there. I'm just going to tack one end up, and then I will come back, line it up, and tack the rest of them up. Once in there, I should be able to take that off now. Just want to make sure that's flush, which it looks to be. And then
Not like that! Not like that! Okay.
Give this
give
clean.
this a clean.
No,
No,
I'm just gonna
very
very
quickly
test the board
test the
again,
board again,
just because
just because I've made changes.
Now that we've checked that the voltages are correct, we can move on to looking at the replacement of the RF module. So as you can see, we'll be, as I'm pointing out here, there's a few connections that we need to deal with, including the 5-volt rail, or power in I should say, and the video in, as well as the connection to the RF jack. Now because we're using the model of the ULA that we have here, we won't need the 555 timer chip in here, which is fine because it's socketed and we can just remove it as needed. These boards are a bit notorious to get off due to the main ground points, but we'll work our way through. So first things first, we need to remove or free the power input line, which is just here, as we can see in this car here, and the video line as well, which come into the can. So what you're seeing here is me just preparing to free up those lines, just heat up the solder underneath and pull the lines out. Unfortunately, I'm about to make a complete muppet of myself.
Look out, Muppets!
Which I will show you in a minute, because I will definitely stuff this up. Okay, so who can guess what I'm about to do? Looks like I'm about to pull that wire out, but then I just realized something. Any second now.
Okay.
Alright,
Right, so hopefully you can see this, but yeah, I literally put my tweezers under that resistor and snapped it in half trying to pull that wire out. Complete muppet. So that's another part I'll have to deal with, but let's just carry on and get rid of the rest of the wires. You would never have guessed I would struggle too much just trying to pull two wires out of a board. Oh, actually, I shouldn't even say pull two wires out, desolder two wires out of a board. But this took me much longer than I care to admit. Okay, now that that's some mozzles over with, we just need to get rid of these ground legs here so that we can get the can off. I'll skip going through this because it's a bit of a laborious process. Suffice it to say, they are not the easiest things in the world to get off without damaging the board. Okay, so with a little bit of a wriggle with the tweezers, the can pops out. There we go.
Oh, congratulations!
So now we can get on with building the rest of the composite mod. I'll just give this board a little bit of a clean. Okay, now the board is clean. I need to find out what size this resistor is. The markings on it, although not clear, suggest it's 680 ohms, but we can check that against the schematic just to make sure. So if we look here right next to the 5-volt rail, it is 680 ohms. Unfortunately, I don't have any of these on stock, so it'll have to wait until tomorrow when I can get down to the shop and pick some up. While I'm waiting to get the resistor, we can get on with putting the composite mod board into the old RF module. So I need to remove the base plate, and there's an installation pad there which we need to keep. We'll need that later on. I'll just put it one side. Now, what we need to do here is, obviously we've got to get rid of those wires. We need to unsolder that point there, and then we need to literally get this board out of this shell, which is not as hard as what it would seem. Okay, so I'll start by just snipping off these wires just to make my life a little bit easier. Preferably without being a complete muppet and slicing anything else in there, although if I did, it wouldn't be a major issue. I like to try and keep these boards if possible, but you know, if you lose it, you're replacing it anyway, and I don't see why anybody would want to go back to an RF from a composite. Okay, so now comes the fun part of trying to desolder this board out of the can. It's held in by a number of solder points, so I'm just pointing them out here. There's 5 of them in total. The big trick with this is to make sure your iron is hot enough to pump enough heat into them, because the can itself will dissipate heat pretty quickly. And as you can see, I'm using my manual engineer's solar pump to do this. You can use if you've got a vacuum pump would be very good for this. This is just quick and easy to hand, and I didn't have to wait for my vacuum desoldering gun to heat up. So pump my iron up. I ended up putting it on about 420, which is way hotter than what I normally run it at, but it just means that this solder will melt nice and quickly. Yeah, me just faffing around, as you do when you're doing these sort of things. And there we go, off and running. And as you can see, it melts the solder pretty easily at this temperature, and one press of the button and cool. The only problem with these pumps, these manual ones, is it makes an absolute bloody mess everywhere. But they do a fairly decent job. So if you don't have a vacuum pump, these work pretty well. just make sure you get a decent one, not one of those like super cheap ones you get in a kit. The plastic ones, they're terrible. Anyway, I will skip forward now because basically this is just rinse and repeat. Once you've got the solder removed with the appropriate application of leverage, the board will eventually just pop out. Now that we've removed the old RF board, we can install the new composite board. So we only need 3 wires here. Whatever colours you want to use is fine. I'm kind of going to go with the yellow, red, black scenario. Yellow for video. It's kind of a traditional, red for power and black for neutral. Once we've got our wires prepped, it's time to start soldering it to the board. So there's only 2 wires that need to go on the motherboard. One is the 5V to bring power into the composite, and the other one is the video in, which as we've mentioned before, comes from pin 16 on the PLA. To speed the process along a little, I'll fast forward through this piece where I'm just soldering these 2 wires on, and then we can have a look at me installing the can. With the power and video input lines connected to the board, we can move on to getting the video output line ready. So we need to solder this to the old RF module out so that we can use that for our composite connection. To do this, we just solder the yellow wire to the RF out, just where the old resistor was originally soldered in. One thing I will suggest is there's a little, it looks like a tongue on the inside of these ports. If you've got to build up a solder and that in there, it can cause issues where the jack won't go in properly all the way. It's supposed to act like a bit of a spring, but if it's got to build up a solder, it won't act as a spring. So just make sure that that's nice and clear. With our wires securely connected, it's time to start installing the composite board into the old RF modulator can. So, not a particularly difficult task. We just connect the yellow wire that we've connected to our RF out port to the video out on the composite board. The red obviously goes to the 5V in on the composite board, and the blue, I believe I ended up using blue wire, goes to the video in on the composite board. Then we solder the composite board into the old RF modulator can, in much the same way that the original RF board was soldered in. One thing to remember is to install the red insulation sheet between the bottom of the composite board and the bottom of the can. This will stop the board from shorting out. I have made that mistake before in the past. You've all seen me doing soldering before in the past, so I will fast forward this and we'll get to testing it.
Did I forget to mention that you also have to solder the RF cap modulator can back onto the board? The actual modulator can provides the ground connections for everything. So, yeah, probably should have mentioned that before. So here we are, finally testing it, and yes, it appears to be working. I did connect a keyboard to this just to test the functionality, and as you can see, everything appears to be working fine. So as I mentioned, this board came just as a PCB, so no case or anything. So I quickly grabbed an STL file and printed up a case, and let's see how it turned out. And here we go, here's the final result. I don't think it looks too bad, but let me know what you think in the comments.